All right, well, we are going to continue to graph lines. Today, though, we're going to work on graphing lines in a different form, what's called standard form. Before we get to that, let's actually start with our opener and have you think about how we're going to graph each of these lines. So I actually want you to do a few things, especially because that graph is kind of small, it's hard to see, but I want you to tell me which form is the equation in. Remember, there's two types. There's either slope-intercept or point-slope form, so tell me the form. Then I want you to tell me where we start at. So what's the starting point? And then what is the slope? Right? So identify those three things for each graph, A and B, and then using the start point and the slope, go ahead and graph the lines from there. So go ahead and hit pause. I'm going to work through it. After you unpause, we'll have the work shown here. All right. So let's start with part A here. So that equation is in slope-intercept form. Ways that we can pick up on that is there really aren't any parentheses, right? There's no number added to y, there's a number added to x, but the slope is already being multiplied to that x, okay? So distinguishing between which form, really important because it's different on how we graph them, right? Or what information we pull from that equation. So slope-intercept, that tells me that we have a y-intercept at 0, 5. That intercept will always be on the y-axis. So the first point that I'm going to plot here is at 5 on my y-axis. It is a specific point, right? X is 0 there and y is 5. So that start point is 0, 5, which is the y-intercept. Then my slope is negative 1/2. So a couple ways of how I could use that. I could go down 1 as my rise and right 2 as my run, or I could go up 1 as my rise and left 2 as my run. Either way, that gives me a slope that is negative. Remember, when we have a negative slope, our line should be going down as we work to the right side of the page. So that's just another way to kind of check to make sure you're doing the correct slope there. The next equation, that is in point slope form. Again, identifying that is really important because it tells us what information we can grab from that equation. So our start point here, x is the opposite sign from what we see, so negative 1. Y is the opposite sign from what we see, so negative 6. So my first point that I'm plotting here is negative 1, negative 6. Then my slope of 3, or 3 over 1, tells me to go up 3 and right 1, or I could go down 3 and left 1. Either way, after using slope, I should get a positive slope line. My line is going up as I work to the right there. Okay, so we've already taken a look at point slope form, and remember the name tells you just about everything, right? Point slope, we're given a point and the slope. Slope intercept, we're given the slope and the y-intercept. So we've already worked with these two forms. Our last form is what's called standard form, and it's where we have x and y on the same side, and then a, b, and c are whole numbers. So let's make a note of that, the a, b, and c are whole numbers. And there's a couple ways of how we're going to graph standard form. Let's look at both of those ways right now. And luckily, we've got a little bit better, more at least more space for our graphs here. All right, so the first method is using a solving tool that we did first semester where we worked to get an equation solved for a given variable. Well, if I have an equation in standard form, we can convert that into slope-intercept pretty easily. So if I want to go from standard form to slope-intercept form, we're just solving this equation for y. So I just need to get y by itself. So I'm going to undo everything that's happening to that y, starting with subtracting 5x. So I subtract 5x and I get 3y equals 15 minus 5x. Then I need to divide every single thing by 3. Okay, and I'm going to write every single term divided by 3 like that because each part, the 15 and the negative 5x, are all getting divided. So it's y equals 15 divided by 3 is 5, and then negative 5 divided by 3, I'm going to leave it like that. I don't want to convert that to a decimal. Having fractions with slope makes it much easier because now I can see my rise over run. And now y is by itself. Yes, it doesn't look exactly like mx plus b because these terms are rearranged. So let's just fix that. Let's put the negative 5/3 x first and then plus 5. And so now I can see that my start point is at 0, 5. So that's my intercept. And then the slope here is negative 5/3. So it's a negative slope line, so I should picture it going down as I go to the right. I'm going to start up at the y-axis at 5, and I'm going to go down 1, 2, 3, 4, 5, and right 1, 2, 3. Down 1, 2, 3, 4, 5, and right 1, 2, 3. And let's just kind of set that as our minimum standard here, and having 3 points to every line, at least 3. Okay, ideally we can get even more. All right, so that's basically it. Let's take a look at one more here where we've got to do something else to the slope here. So same idea, change the slope-intercept form. That means we're going to take this equation in standard form and get y by itself. So I'm going to add 10x. It's 12y. This time I'm just going to do the rearranging right away. So 10x plus 60. So I just add 10x to that other side. I wrote the 10x before the 60. Then I'm going to divide by 12. So that gives me y equals 10/12 x, and then 60 divided by 12 is 5. Now, what's not the most convenient here is the slope of 10/12. I'm not going to be able to do that two different times to get 3 points on this graph because of how big those numbers are. So what I'm going to ask us to do is take that 10/12 off to the side, and we're going to work on what's called reducing it down. Top and bottom by any numbers that they share in common. So 10 and 12, I can divide both those numbers by 2, making this 5/6. 5/6 is the same fraction as 10/12, and you can check that on your calculator. And now by having that slope reduced down, me doing a rise of 5 and a run of 6 allows me to plot more points on this graph. So this is really y equals 5/6x plus 5. Now, do you need to do this? No. Okay, you don't need to, but reducing fractions is a really important step in algebra, and again, allows us to work with just some smaller numbers, and in this case, graph a little bit better. So here, our start point is at 0, 5 once again, and then my slope is at 5/6. So I'm going to go up to my y-intercept at 5. My slope of 5/6 has me going up 1, 2, 3, 4, 5, and then right 1, 2, 3, 4, 5, 6. My slope or my line should be positively sloped, so that means going up as I go to the right, which so far that's the case. So I can get another point now by reversing that process and going down 1, 2, 3, 4, 5, and left 1, 2, 3, 4, 5, and 6. And there is our 3 points. All right, I'm going to have you all do one example on your own. Actually, 2 examples on your own, 3 and 4. So go ahead and hit pause. First, get y to be by itself. Then identify your start point and slope. And if possible, reduce any fractions if you're able to do so. After you unpause, we'll have all the work shown. All right, so here's all your work. Let's start with number 3 here. So getting y by itself. First, I'm adding 6x and then dividing every single term by 7. Nothing needs to be reduced down here. Our slope just ends up being 6/7. The y-intercept ends up being 0, -6. My first point is down 6 here. And then using a slope of 6/7, we're really only able to plot 1 point on this graph. That's okay. You can, if you're like, hey, Mr. Youngren said we need 3 points. If you got to go off the graph, not a big deal. You could go down 1, 2, 3, 4, 5, and 6 and kind of estimate where that would be. And then over 7 takes me over to here. So you could extend it off the graph. Really not a big deal if you do or do not do so. Okay, but 2 points works there since we can't fit any others on that actual graph. All right, number 4. First, getting in the slope-intercept form, minusing 15x, then dividing every single term by 9. -15/9 is our slope. Then 45 divided by 9 is 5. -15/9. I just want to check. That looks like it can be reduced down. A lot of times with these bigger numbers, we can reduce them down. And the way that we reduce them down is divide the top and bottom by any number they share in common. In this case, 3. So -15 divided by 3 is -5. 9 divided by 3 is 3. So that's how my slope went from -15/9 to now -5/3. So slope is -5/3. My y-intercept is 0, 5. So I'm going to start up 5. And then I can use my slope of -5/3 by going down 5, right 3, and down 5, right 3 again. Okay, so that's one method for graphing in standard form. Just simply convert it into slope-intercept. The other way that we can graph a line in standard form is to use its intercepts. And this is actually the most efficient way to graph these lines because we don't have to do a lot of work. So x-intercept, if we don't know, remember this is where the graph crosses the x-axis. Y-intercept, we've been working that, but just a reminder that it is where the graph crosses the y-axis. Now, because we know that a point, an intercept, is on the axis, that tells us about that specific point. So let's start with the x-intercept. Okay, this a comma 0, what that's telling us is that when we're looking at the x-axis, every point that is on the x-axis has a y-coordinate that is 0. That's a 0 right here. So for me to find the x-axis or the x-intercept represented by this variable a, I need to let y equal 0. So I plug in y equals 0, and I solve for x. That's all that we need to do. So let's look at that work here. X-intercept, I'm going to plug in y equals 0. So I'm going to take this equation. I have 5x plus 3 times 0 equals 15. And plugging in the 0, we multiply by that 0, and it goes away. And it goes away really quickly. So now, for me to find the x-intercept, I just need to get x by itself by dividing by 5. And I get that x equals 3. So my x-intercept is 3 comma 0. A in this case would be 3. The y-intercept, almost the same idea, but now we're looking for where the graph crosses the y-axis. Every point on the y-axis shares an x-coordinate that is 0. That's what this is saying here. And we're going to get a different y-coordinate for every y-intercept, in this case represented by the variable b. So to find y-intercept, I plug in x equals 0. So let x equals 0. So 5 times 0 plus 3y equals 15. Well, 5 times 0 is 0. I get 3y equals 15, and thus y equals 5. So our y-intercept here is 0 comma 5. So really, for us to define a line, we only need 2 points. So I'm going to go to 3, 0, 5, 0. This is all that we need to graph the line. I can connect these points, and boom, we are done. Now, if you wanted to get a third point, we can figure out the slope from these 2 points right here pretty easily, right? I'm having to go down 5 and right 3. So I could get a third point by doing that exact same thing, going down 1, 2, 3, 4, 5, and right 1, 2, 3. There we go. We are all done. All right. So you need to know both ways, finding the intercepts and converting. And we are going to do both as we work through this. So let's do this. Let's have you all do number 6. Or you know what, I'll do 6, and then let's check 7 and 8. I'll have you do both of those on your own. So I like the setup that I showed you all before, where I go x-intercept, y-intercept, and then right underneath, I write how I'm going to do that. So y equals 0, x equals 0. And then I'll just do the work from there. So let y equals 0, so negative 10x plus 12 times 0 equals 60. 12 times 0 goes away, so I get negative 10x equals 60. And thus x equals negative 6. So negative 6 zeros that x-intercept. For the y-intercept, x is 0 now, so plus 12, y equals 60. Negative 10 times 0 goes away. I get 12y equals 60. Divide by 12 and get that y equals 5. So 0, 5 being the y-intercept. Now I can plot those. 0, 5, negative 6, 0. Let's even use the slope here. So in this case, I'm going to go right 6 and up 5. So right 6 again and up 5 takes me to the very top of the graph. And now I have 3 points. And there we go. Okay. Let's have you all do 7 and 8. Again, I like this work. It really helps your brain process what needs to happen from one step to the other. And it makes it easy for me to see kind of what thoughts you have here. So find each intercept. Go ahead and graph it. See if you could even use the slope once to come up with a third point. Okay, go ahead and check your work here. Again, I've got all the work shown for the x-intercept, y-intercept in both cases. For number 7, the x-intercept ends up being positive 7. The y-intercept ends up being 0, negative 6. This is that case where to find our slope here, It is pretty, there's big gaps. So our second, if we want to add in that third point, ends up bringing us off the graph. Again, that's okay. You don't need to, but it does help us get that third point, even though it is slightly off. Number 8, same idea. X is 3, Y is 5. That one's a little bit easier for me to replicate that slope because I can fit it on the graph pretty easily by going down 5, right 3. So down 5, right 3 again. And then just in case we're confused, that 0, 5 is pointing to that point there, 3, 0, that point there. All right, that is it for today's lesson. You now have a homework to finish. Make sure you grab that from the sub. Have a great day.